Welcome to the lecture on engineering materials. I have classified this materials lecture into three parts. For manufacturing, understanding materials is very important. Moment I understand the material, its performance in terms of mechanical properties and service condition exposure, I can do better manufacturing. When we do a proper efficient manufacturing, it always leads to customer satisfaction, reliability and repeatability of the product. So, in this lecture, we will try to have an introduction, followed by it will be metal and classification, composite and its type, ceramics and polymer and classification. Understanding materials always leads to material science. Material science involves investigating the relationship that exists between structure and properties. When we talk about any metal, we always try to talk about the properties in a macro scale. But moment you wanted to talk in terms of micro scale, today we talk about a new area called grain engineering. I know this is what is the output required for the customer or in the product. So, now how do I design or tailor make my grain? You can make the grain larger, smaller. You can try to have around the grain some precipitation. All these things are possible. So, if I have to do this, I have to understand material science. This involves a relationship between the structure and the properties. The material science is primarily concerned with the search for basic knowledge about the internal structure, properties and the processing of materials. How do I get the material processed? There are two things we are talking about: material processing and manufacturing process. When I talked about grain engineering, it all goes around the material processing. So, material science is primarily concerned with the search for basic knowledge about the internal structure. Internal structure is nothing but the grain. Every material is made out of grain, right. So, this is a grain and this is the material. I am taking a material, typical material, and I am trying to segment it into small parts, and those things when I look into a microscope, I try to see this grain. So, a material is made out of grain. So, internal structure are nothing but the grain, and along the grain what we call it as grain boundary. This is very important. The size of the grain plays a very important role. So, you can enlarge the grain, you can shrink the grain, you can stop the grain movement, you can play with it, right. All these things are material science. Internal structure, properties and the processing of the material is material science. So, material science gives you the basic knowledge. Material science and engineering result is nothing but a resultant knowledge of structure, property, processing and performance of engineering material is material science and engineering. The engineering material what we use is nothing but applied knowledge of materials. So, you can now clearly distinguish material science and engineering materials. So, this understanding is very important, because based on this understanding we will try to choose a process. When we look into engineering materials, materials that are used as raw material for any sort of construction or manufacturing in an organized way of engineering application are known as engineering materials. So, we know there is a material available, we have to convert this into a part. We know there is a material converted into a part. So, that is what we call it as materials that are used as raw material for any sort of construction or manufacturing in an organized way. See, why are we talking about organized way? Because organized way means you are trying to have a controlled process. Why controlled process? Because every time you try to make, you should get the same output. So, organized way of engineering application are known as engineering materials. The materials can be classified into many ways. The most basic and fundamental way are they are classified into three parts. One is metals, non-metals and material due to combination. Right? You are trying to combine material here maybe between A and B of metal or metal and non-metal to get an output. Right? So, they are classified into three basic steps: metals, non-metals and material due to combination. It might look little surprising. Today, if you try to look at a domestic application, non-metals play a very significant role, More amount of polymer products are available today. Let it be automobile, let it be your ordinary kitchen utensils, let it be now heavy strength materials, non-metals are coming in a big way. Under metals, you have two basic classifications which are nothing but ferrous and non-ferrous. When we talk about ferrous, we try to talk about steel. Again, in steel, you have classifications. So, ferrous means steel, stainless steel utensils, what you use at your home, high carbon steel, high strength steel, low weight, high strength steel. So, steel is part of ferrous. When we talk about non-ferrous, copper, zinc or a combination of copper, zinc, brass, bronze, tin, okay, these are multiple things, aluminium, then you have magnesium, okay, these are all different types of non-ferrous materials. All these non-ferrous materials are exhaustively tried today because of its light weight. For example, 40 years, 50 years before, we were using as white body material, we were using steel. Now, we try to use aluminium. The folding chairs were made out of steel. Today, we are trying to make this out of frame structure where aluminium is exhaustively used. So, aluminium are light in weight, it has better environmental resistant conditions. So, they are exhaustively used. When we want to make engineering materials, we try to have all these non-ferrous material getting mixed into the iron material to give a better performance. That is what we are coming under the alloy classification. When we talk about ceramics, there are again two classifications of ceramics. One is oxide ceramics and the other one is non-oxide ceramics. Oxide ceramics are alumina, silicon dioxide, etc. as part of oxide ceramics. Non-oxide ceramics are titanium carbide, titanium nitride, silicon carbide. These are some of the non-oxide ceramic materials. As you know, ceramic materials have high temperature resistance property. That means to say it can withstand very high temperatures for whatever application you want. Organic polymers. The polymers can be classified into three parts. One is thermoplastic, thermoset and elastomers. Elastomers are nothing but rubber. So, again this can be further classified into thermoplast, thermoset and elastomers. Now, let us move to the next classification, which is materials due to combination. You have composites and alloys. Composites are material where you have two major components. One is called as a matrix, the other one is called as the reinforcement. The matrix can be made out of metal, ceramic or polymer. The reinforcement can be made out of ceramic or metal to meet to the engineering requirements. We will see this more in detail, but when you try to take these composites are further classified into several parts. They are classified as natural fiber. When I said the reinforcement, you can have a natural fiber reinforcement, you can have a metal reinforcement, right? You can have a ceramic reinforcement, which is glass as a ceramic material. So, that is called a ceramic polymer reinforced composite. You can have carbon fiber reinforced polymer. You can have in a metal ceramic getting dispersed or in a polymer metal getting dispersed. All these combinations are possible today. And apart from all these things, you can also try to have hybrid, which is a combination of multiple things. Hybrid means you try to take A, B and C to meet to the engineering requirements. So, composites are classified into several types. Again, the basic thing in a composite, you will have a matrix and a reinforcement. The matrix is basically to hold the reinforcement so that you can get high strength properties or hybrid properties. When we talk about alloys, alloys are again classified into ferrous alloys and non-ferrous alloys. What I gave an explanation here, steel when it is mixed with non-ferrous material, it forms a ferrous alloy. You can also have non-ferrous alloy like bronze, brass. These are all non-ferrous alloys. Okay. So, fundamentally, if you see engineering materials classified basically into three types: metals, non-metals and materials due to combination. This is very important understanding. Suppose you wanted to have very high strength, very light in weight, then get back to this table and find out, should I use ferrous, should I use ferrous alloys, should I use non-ferrous alloys or should I go for composites. We will see the properties little later in the discussion. So, when we talk about metals, there are so many metals, it is a huge menu. In the menu card, you will have huge metals. So, aluminium, which is commonly used, steel, iron, copper. Today, copper is exhaustively used for high conducting applications. Copper, brass, which can be used for fittings, which can be used for artifact making. Then bronze, these two, brass and bronze, are used for artifacts. Artifacts means some display items. Bronze is also used. Then you will have cobalt, chromium, magnesium, aluminum and magnesium, titanium. These three are exhaustively used in automobile application today. It is not used as pure material, it always has a combination. So, we always talk about aluminum alloy, magnesium alloy, titanium alloy for various applications today. In biomaterial application, titanium alloys are exhaustively used. You have nickel based alloys. Nickel based alloys are used for exotic application. For example, today you have high strength, high temperature, non-corrosive, we go for nickel based alloys. Then lead, which is very heavy, lead is used, tin, zinc, right. Then you also have tungsten. Tungsten is a heavy material. Today we are trying to do many of the aerospace application tungsten based. Platinum, gold, pure gold has no value. Gold, when it is mixed with an alloy with copper, helps you in making an ornamental purpose. Then you also have silver. So, you see there is a huge spectrum. You can have one metal, you can have two metal combination, you can have three metal combination. Today they are trying to have 6 metal combination also to meet out to the requirements. Metals are elemental substance capable of changing their shapes permanently on applying a force. They are generally good conductors of heat and electricity. For example, if you want to look for a vessel for boiling water, good conductor is required. If you are looking for transmission of electrical power from one place to the other, we go for copper cable. So, electricity is very important. There can be ferrous and non-ferrous type also. So, when it is steel, it is ferrous, non-ferrous type also is there. The behavior and the properties of the ferrous material depend on the percentage and combination of carbon in it. So, moment in steel you try to add carbon in it, the performance of the material changes. The ferrous metals have Fe as a major constituent. As an example, you can try to look at steel. Say for example, titanium, you can have Ti6Al4V. You can have this combination, right. When we talk about gold also, we try to have AU and then copper combination you can try to have. Silver is again Ag and Si combination you can try to have, or you can try to have copper combination into that, depending upon your requirements. So, now it is clear, depending upon the addition, you can try to have various strength properties, you can try to have heat conducting and electrical properties. When we look into polymers, polymers are made out of C and H, carbon atom, hydrogen atom, and then you can try to have some other atom to bring to the or add value such that you get a good engineering application. Most of the polymer material consists of organic carbon content. These carbon content are all formed into a chain. There in metals, I was trying to tell you, they are made out of grain. So, here these carbon gets fixed in a chain. So, this chain is called as molecular chain. They are always long. There is a long molecular chain and all the carbon and hydrogen sticks here. And when you have carbon and hydrogen sticking here or this combination sticking here, so individual block is called as a mer. Several of these mers join to form a polymer. Most polymeric material consists of organic long molecular chain or network. If you have a long molecular chain, you will have a different application or different properties. If you have a networked, you will have a different property. So, if you have a long chain, free chain, and if these free chains are not attached anywhere, so then what happens? The free chain keeps on moving. So, you will have more amount of mobility. So, the ductility will be very high, right. Moment you start pinning the chain, right. So, that is called as cross linking. When you cross link, the chains do not have the freedom to move left or right. So, they are all held rigid. So, now when we try to have such polymers, you will try to have high strength. So, you can also have branches which is there on the polymer. In the polymer molecular chain, you can also have branches. These branches are fixed by some functional group. Okay. So, when the functional group is added, these small chains, they get attached to a long molecular chain. So, by looking into the structure, you can try to have multiple or varying properties. Structurally, most polymer materials are non-crystalline in nature, but some polymers have a combination of crystalline and non-crystalline regime. So, you can have a polymer where it is partially crystalline and partially non-crystalline. So, non-crystallinity gives you a different property as compared to that of a crystalline polymer. the strength and the ductility of the polymer material vary greatly. The big difference between metals and non-metals, for example, with respect to polymers, is it has poor conductivity of electricity and heat. So, when we try to look at a vessel in your kitchen, we always try to make a handle out of it. This handle will have poor conductivity of heat, right. When you have a kettle, you will have a poor conductivity of electricity, because in a kettle what you do is you heat it by electricity. So, poor conductivity of heat and electricity is obtained in a polymer. So, the handle whatever you see in a vessel is made out of polymer. You can try to add more amount of branching, cross linking and all, and you can try to make it out of polymer. You get try to have a bakelite, and that is used for holding. Some of these materials are good insulators and are used for electrical insulation application. For example, you have a wire, the wire is covered, right, is covered by a polymer material. This can be a rubber based material, elastomer. So, this makes it a poor conductor. So, it is called as insulation. The wire, this is copper wire or aluminum wire. In general, polymer materials have low density and relatively low softening decomposition temperature. So, this low density means the weight is low. So, when we make the cables are hung on top of a ceiling. So, if it is heavy, then you will have to make proper fixtures to hold. So, since it is light in weight, you just strip it or stick it on top of a ceiling. So, low density means low weight. So, when we take a kettle, again the low density gives you a bigger advantage. The handle becomes very light. You can always have wooden handle, but wooden handle is heavy. Wooden handle absorbs water. So, polymer does not absorb water, right. So, that is what it is, and then it is relatively low decomposition temperature. So, what does it mean? When we apply a very small temperature, you can try to deform. This property is not there in metals. So, basically when you try to work with metals, you should always try to use higher temperature. So, you spend more energy to deform and get the final output. The polymer materials are relatively inert and light, generally has a higher degree of plasticity, ductility. They are derived mainly from hydrocarbons. They consist of covalent bonds formed by carbon chemically combined with oxygen and hydrogen. The word mer, see this is what, mer plus mer plus mer leads to polymer. The word mer in Greek means a unit, mono means one and poly means many. Thus, polymer are obtained from monomers bonded by chemical reaction called as polymerization. In this process, you get a long chain having higher molecular weight. When we try to have a comparison between metals and polymers, the molecular weight of polymers are generally in several thousands, whereas here it will be very less. Why? Because the molecular weight is calculated by number of mers put together. Bakelite, polyethylene, nylon, Teflon are some of the examples. Teflon, where do we use? Wherever we wanted to have a fitting, and where in the fitting we wanted to have a leak proof, we always try to go for a Teflon tape. So, this is what I said, it will have high degree of plasticity, right. You can try to wind it. Nylon is exhaustively used for again fittings. You can have nylon fittings in taps, right. So, they have toughness and they can be easily made. So, polymer material classification. So, here polymer again is classified into two types. One is natural polymer, the other one is synthetic polymer. Synthetic polymer means it is artificially made. Natural polymer means you extract it from a tree or something. For example, rubber is extracted from a tree, a syrup comes out. So, that is natural polymer. So, again in natural polymer you have two types. Proteins are natural polymer, then polysaccharides. They are also a part of natural fiber. So, some examples if you see here, these are some of the examples. Dextane, these are some of the examples of polysaccharides. So, when we talk about proteins, we try to have gelatin, colloidal, albumin which is seen in egg. These are all part of proteins. They are all natural fibers. Now, when we try to talk about synthetic fiber, you have polyethers, then polyesters, then we have RP polymer, we try to have polymers. So, under polyether we have PEGs, then we have PLGA. These are all classifications and you would have used this or seen this when you try to look at the specifications of a product. Then this is CPP, or you can have is lactines. Okay. So, when we look at polysomers, you will have PF127. So, now it is very clear that the polymers can be produced synthetically. So, synthetically means I try to do polymerization process, and by polymerization process I can try to functionalize, add a branch or try to form network or try to form the rigid structures. So, here are some of the major applications of polymer materials. It can be used for making micro capsules for self-healing material. Self-healing material means you try to take a material, you try to puncture or you try to crack the material. When these self-healing capsules are put, these cracks are arrested and closed. So, these are micro capsules which are made out of polymers, which has self-healing properties. You can try to have surface coatings out of polymer. So, the surface coating, when we try to have an internet cable, when you try to cut it, you see optical fiber covered with a rubber material, or you can try to take a wire, copper wire insulated with a rubber like structure material. So, surface coating, you can also try to do a flat coating, polymer coating on top of a metal surface, which will prevent from chemical reaction and rusting. You can also have polymer materials for trackifiers for the tire compounds. So, there are rubber materials which is also falls under polymer, which is exhaustively used. So, these rubber are vulcanized, you can see the several wires around it. You can also try to have some shapes which is given on top of a tire, such that it can increase its performance. Then you can have light curable dental composites. So, today what we do is, when you go to a dentist for filling your teeth, for a teeth which is decayed, he makes a paste, keeps the paste on the cavity, and then he exposes it to a UV light or some light, such that it accelerates its curing. So, you can use it for dental cavity, light curable dental composite. You can have plasticizer, PVC plasticizer. PVC bottles are there, PVC lids are there, and kids toys are made out of PVC. So, they are used, and nano emulsion for drug delivery is also used. So, polymer finds its application in nano drugs, in automobile, in healthcare, in toy, in self healing. These are new materials, self healing, and then you can also use it for surface coating. Again, where is surface coating used? It is exhaustively used in automobile or household. So, now you see polymer is spread at every part, every segment polymer materials are available, and each and every process for making the output is different. Moving to ceramics. Ceramics are inorganic material. Polymer we had organic, and under organic we had a classification thermoplast, thermoset and elastomers. Then when we try to take polymer, we had synthetic and natural. But when you come to ceramics, it is plainly inorganic material which consists of metallic and non-metallic elements bonded together. Ceramic materials can be crystalline, non-crystalline, or a mixture of both, like what you had in polymer. Most ceramic material have very high hardness and very high temperature strength, which is not possible either in polymer or in metal. Why is very high hardness required? Because this tries to give you a scratch resistance. High hardness means when you have a material, if you want to indent the material, it is not possible, or if you are trying to, if there is a scratch which is there, it will not so easily happen if you have a high hardness. Of course, scratch can also talk about toughness. So, high hardness and high temperature strength, but has a very poor mechanical property. That means to say, it is very brittle. Glass has very high hardness. In a glass, if you want to scratch by your nail or by a spoon, it is not possible. But when you drop it, it shatters. So, that is what we say, high hardness, high temperature strength and brittle. The microwave bowl what you use has very high hardness. The bowl can withstand very high temperature and it has a very poor mechanical property, it is brittle. The advantage of ceramic material are light in weight, high strength, high hardness, good heat wear resistance, reduced friction, insulating properties. These are all the advantages. So, that is why ceramics are exhaustively used. For example, in chemical plant, we will try to have a hose which is basically made out of polymer coated inside with ceramic material. The ceramic material will try to give us more corrosive resistance, wear resistance, right. The insulative property along with the high heat and wear resistance of many ceramics makes them used for furnace lining for high temperature of liquid metals on steel. See, when you have to boil something, so this is a material, when you have to boil something and if this material has to boil or heat at 1500 degrees Celsius. So, naturally the container whatever is there has to be made worth for 2000 degrees Celsius or 1800 degrees Celsius, because you are trying to heat. So, if that is the case, we always try to use for insulating material, right. So, insulating material. So, that is why if you take furnace, the lining or the holding will be made out of ceramic material. The ceramics are also classified into two, which is called as traditional ceramic and advanced ceramic. Earlier I classified into oxide and non-oxide, but here we are classifying it in a different fashion, which is called as traditional ceramic and advanced ceramic. Advanced ceramic means they have been used for some engineering application. So, in traditional ceramic we have clay products, we have glass, abrasives which are used in grinding wheel, refractory materials and cement. When we look into advanced ceramics, we have alumina, aluminum nitride, diamond, which is lead, zirconium titanate, silica, this is SiO2, silicon carbide, SiC, zirconium oxide and many more things. So, these things are called as advanced ceramics because they have manufactured to meet out to certain requirements. This lead zirconium titanate, this has a very interesting property. When the material is stressed, it expands and contracts, very interesting property, right. So, the ceramics can be classified as traditional ceramic and advanced ceramic. So, here are some of the examples where you see lot of applications. If you see IC chip, silicon wafer, it is all a ceramic material. You can see these are all alumina, Al2O3. These are some of the things which are used for engineering applications. You have in ball milling operation for grinding of powders, we use zirconium oxide balls, right, when you want to hammer and break. So, we try to have these balls. So, you can see this. When we talk about traditional, you can see glass, clay, pottery which is used, and you can see all these ceramic utensil like applications like cup and other things. So, these are all traditional ceramics. So, advanced ceramics are playing a very important role. In polymer composites, we are trying to have ceramic material also integrated. So, now let us look into a new classification. Till now what we saw was, we saw metal, classification of metal, polymer, classification of polymer, ceramic and classification of ceramic. These three are very important. Moment you understand this, then you can quickly go ahead and generalize some of the properties which we will see. And why have you to know this? Because we have to choose a proper manufacturing process to meet out to the product requirement. Now, let us get into a new material which is called as composites. Composites are materials made from a combination of two or more constituent materials with significantly different physical and chemical properties. If you look at it, you will have a fiber which is a ceramic material, right, a matrix which is a polymer material, completely different properties. Insulating, you can have conducting, non-conducting, whatever it is, lightweight, heavy, you can have all these things playing. So, having different physical and chemical properties, wherein which fiber and matrix are infused or they are merged or they are beaten together to form a composite material. When combining, they produce a material with characteristics different from the individual. When you try to mix these two, fiber loses its property, the matrix loses its property and you get a hybrid property. However, when you cut the material, you can clearly distinguish where is the fiber and where is the matrix. The constituents remain separate and distinct within the finished surface. In alloys, when you try to mix, it is very difficult to distinguish where is the X metal and where is the Y metal. But in composites, when you cut a section, you can try to find out individuals like fiber, polymer, where is it, and you can see them clearly. So, here they both get blunt to give a synergetic property, that is nothing but composites. The composites may be inorganic or organic. Why? Because polymers can be organic. So, it can be ceramic based, it can be metal based, or it can be polymer based. They have two or more constituents of dissimilar properties. The two major constituents can be metal and ceramic, or metal and polymer, or ceramic and polymer, or other combinations. When we try to compare with alloys, alloys may also use instead of metals to make composites. So, one of the constituent called reinforcing constituent may be in a particulate form, fibrous form, or in a flakes form. So, the reinforcement whatever we are saying, it can be in a long fiber, it can be in flake form, it can be in particulate form, it can be in a fibrous form. The fibers can be short, this can be short, or it can be long. It can be weaved, it can be individual fiber. Okay. So, whisker reinforced composites are also gaining lot of importance today. So, these are the fibers. When you try to cut a cross section, you can see fibers and you can see matrix. The function of the matrix is only to hold the fiber, right. The fiber gives you the strength. So, here you can clearly see the matrix, large particles, you can see matrix and nano size particles. Flakes are also in between, or it can be larger than the large particles. Okay. So, the types of composites can be fiber reinforced composites, where the reinforcement with fiber enhances the strength and stiffness. So, you have glass fiber reinforced, carbon fiber reinforced. Wherever you are trying to have a very high toughness, for example, bulletproof jacket, you have a nose cone made for helicopter or fighter jets. They are all made out of carbon fiber reinforced polymers. They are light in weight, higher toughness, withstand higher temperatures as compared to that of glass fiber. Used in boats, sports gears and auto parts. The particulate reinforcement composites, they are used to improve the hardness and strength. For example, concrete, cement with gravel or sand used in construction is a particulate reinforcement. When we try to talk about brake shoes, brake pads, they are all metal reinforced with ceramic for in automotive and aerospace application. So, if you try to take a typical A380 Airbus plane, you see where are all the parts which are all used to be made from composites. You can see ceramic fiber reinforced, new aluminum alloys which are there. You can try to see in the wings where CFRP is used. Then inside they are using glass fiber reinforced. They also have carbon fiber reinforced web ribs. Then this nose part also today they are trying to make out of composites. Glar is used in the upper fuselage, so that the material is light, which has lot of engineering properties like high stiffness, all these things, such that it can withstand very high temperature. See, you should understand the flight typically travels or moves from 45 degrees Celsius to minus 30 degrees Celsius or minus 20 degrees Celsius. That is the temperature range, it varies. The speed varies from start is 0 kilometer per hour to 800 kilometer per hour. Look at the speed, right? And here it undergoes tremendous shock. When it goes up or down, it undergoes a tremendous shock. So, all these properties are obtained by composite materials. When we try to talk about non-ferrous, so non-ferrous do not contain Fe or C as the constituent. So, you have aluminum, copper, silver, nickel, zinc, tin, chromium are some of the examples. Aluminum, copper, silver, gold are good conductors of electricity. They are also having good heat conducting properties. Silver is malleable, gold is most ductile, chromium is the corrosion resistant material. So, today we take nickel and chromium we add to get an exotic material property response. Zinc is used for metal painting, tin is used for making bushes. So, you see non-ferrous material having lot of applications. Metals are generally classified based on basis of their iron content as ferrous and non-ferrous material. Ferrous, they are again classified as steel and cast iron. An alloy of iron and carbon known for its high strength and versatility is called as steel. Moment you say steel, you should understand it is not iron, it is iron plus carbon. You will have other ingredients, but these two are dominating. When we talk about cast iron, it is iron alloyed with carbon and silicon. So, here the carbon percentage will be more in cast iron as compared to that of steel. So, it is known for their excellent castability and wear resistance. Typically, the iron will have magnetic property prone to rust and corrosion without protective treatment and generally possesses high tensile strength. So, these are the characteristics of steel. That is why we call stainless steel. We add certain elements, the rusting will not happen, whereas in a mild steel, you will see generally rusting happens. So, the ferrous metals are classified into ferrous and non-ferrous. In ferrous, we are classifying it under steel and cast iron. When we talk about alloy, alloy is a combination of two or more metals. They possess properties quite different from those of their constituent material. Alloy is prepared for a specific purpose to meet a particular requirement or application. The alloy may be ferrous alloy or a non-ferrous alloy. When we look into the properties, these are the very important properties which you should always look into. You choose any material, but look into all these properties so that you can get what you want. When we talk about the properties, mechanical properties are creep, fatigue, toughness, hardness, impact, ductility, malleability, resilience and brittleness. Creep is you have a constant load which is applied to a material. So, that what is the response? Fatigue is you repetitively do an operation and see, for example, opening and closing of a door, a spring takes that load, that is fatigue. Toughness is you try to jump on it, or if there is a spoon which falls down and from a certain height, it will not break, it will not shatter. So, that is toughness. Then you have hardness, right? You have impact, toughness and impact get along. Ductility and malleability. Ductility is the way you can draw, the way you can bend. Physical properties are density, melting point, color, shape, size, finish and porosity. So, these are all the physical properties. When we talk about thermal properties, it is expansion, conductivity, specific heat. Specific heat is very important, because when you try to apply heat and when you try to deform, you should know what happens. Specific heat, thermal fatigue, thermal stresses, thermal shock and latent heat of fusion. Thermal shock is the plane from 20 degrees Celsius, it goes to minus 30 degrees Celsius. Magnetic properties such as hysteresis, retentivity, permeability, susceptibility and reluctivity. So, all these things are magnetic properties. When we talk about electrical, resistivity, conductivity, dielectric constant and dielectric strength are some of the electrical properties. Chemical is corrosion resistance, passivity, and then you will try to have acidity, alkalinity and oxidation. So, chemical properties are very important. That is why we use Syntex tank or polymer tanks for holding chemicals. Nuclear is half-life period, decay constant and radiation absorptivity. When we talk about optical, reflectance, refractance, transmission, fluorescence, lustre and luminescence. So, all these things are optical properties. Acoustic is also very important. When you try to make a product for aesthetic application, we like to see sound reflection, absorption and damping. When we talk about metallurgical, phase rules, solid solution, crystallization, rate and diffusion is important. Cryogenics are also an important property, where when do you see ductile to brittle behavior, low temperature impact behavior, very low temperature phase change. Then structural, we have strength, stiffness, elasticity and plasticity. So, next one is friction, adhesion, wear and erosion. Aesthetic is feel, texture, appearance and luster. On top of all these things, you have various technologies which are whether it is weldable, machinable, formable, castable, fabrication ability and hardening ability. All these properties are very important when we try to choose a material. So, you have to put this table and see what properties you want and which material to choose. So, these are some of the standard reference which we have used for preparing this slide. I hope you would have understood the classification of ferrous, non-ferrous, composites, alloys in detail. Thank you very much.